All right, in number one, we want to look at what's the largest GCF that I can take out, and I can see an 8 in each one, and I can see they both have an x plus 7. Now that's x plus 7 to the 8th, that's x plus 7 to the 7th. So I know I can take an x plus 7 to the 7th out. So let me kind of keep track of this. I know I can take an 8 out, x plus 7 to the 7th. What about x's? I can see an x there and an x, so I can take an x out. So that's what we're going to do. And let's see what is left. Of this first term, the 8x is gone, x plus 7 to the 8th. I still have an x plus 7 left behind. That 8 is gone at the second term. I still have a 4x that's left behind. And then we can kind of clean this up. So 8x times x plus 7 to the 7th times 5x plus 7. And that would be it. So that's been factored completely. All right, in number two, I'm going to go ahead and rewrite that square root in its fractional exponent form so we can kind of see what our GCF would be. So that would be 5x plus 1 to the 1/2 power, and 3/2 x squared, 5x plus 1 to the negative 1/2 power times 5. Okay, so let's kind of look at each half here and see what can I take out of both. And let's see, 6, and I got a 6, and I got a 3/2. Well, I know I can at least take a half out, and I know 3 goes into 6, so I can take a 3/2 out of both terms. Let me look at the x's. I see an x and an x squared, so I can take an x out of both. I see a 5x plus 1 to the 1/2 and a 5x plus 1 to the negative 1/2, and we know that we can take out the smallest exponent of a negative 1/2 from that one. And let's see what's left. And then the 5, can't do anything with the 5 for right now. So when I take out the 3/2 from the 6, so that's, think of it like dividing. So if I take 6 over 3/2, what does that simplify down to? Well, that's the same as 6 times 2/3. 3 goes in there twice, so that actually makes that a 4. So that 6, when I divided out that 3/2, that became a 4. That first x is gone, and we have 5x plus 1 to the 1/2 minus a negative 1/2. Because remember, I factored out that negative 1/2. The second half of this set of terms, I already took the 3/2 out. Of the x squared, I have an x left, and I have a 5 left. All right, well now what do we have? Gotta switch colors here. So we got a 3/2 x, 5x plus 1 to the negative 1/2. Inside here, the 1/2 minus, that becomes a 1, so that's really 5x to the first power. So if I distribute that in, I get 20x plus 4 plus 5x. And then I can see that there are some like terms that I can combine. So 3/2 x times 5x plus 1 to the negative 1/2 power times 25x plus 4. All right, so I am done factoring at that point. Okay, in number 3, again, we'll look for GCF. So let's start with our 18 and our 4 here. And now they don't have anything in, I can't take an 18 out of a 4, but I can take a 2 out. So we're going to start with that. I've got x squared and x to the 4th. X squared I can take out of both of those. and x squared minus 1 to the negative 3/2 power I can take out of both, and then I can just start looking at term by what's left. Okay, so if I take a 2 out of the 18x squared, that leaves me with 9 behind, and the fact that I took out that x squared minus 1 to the negative 3/2 means that I am going to subtract a negative 3/2 from the negative 1/2. And then the second half of this expression, let's say I got a 2 left, I got an x squared left, and that x squared minus 1 to the negative 3/2, that's what I factored out, so that's pretty much gone at that point. Alright, so what do we got now? Let's see, so we got 2x squared times x squared minus 1 to the negative 3/2. Here we got 9. Okay, so negative 1/2 plus 3/2 is 2/2. So I got 9 times x squared minus 1 minus 2x squared. I can distribute that in. So 2x squared, x squared minus 1. See, 9x squared minus 2x squared is 7x squared minus 9. And that seems pretty good to me. I think we're done at that point. I don't really see any difference of two squares or anything like that. Oh, forgot my little exponent there of negative 3/2. Sorry about that. Okay, so there's that one. All right, so number 4, I'm gonna rewrite this real quick because we have a lot of rules dealing with negative exponents. So sometimes if we see fractions, we're not quite sure what can come out of that. So I'm going to rewrite this as negative 1x to the negative 2, because that's what x to the negative 2 in the denominator means, is it's really a negative exponent up in the numerator. X plus 2 to the negative 3/2 minus 3/2 x to the negative 1, x plus 2 to the negative 5/2. Okay, so hopefully it's a little bit easier now to see what we can take out. So let's start with let's start with the negative. I know I can take a negative out of each term. I know that, let's see, I got the half, I got the 3/2 and an x squared. Well, I can take a half out, and I can take an x to the negative 2 out, and I can take an x plus 2 to the negative 3/2 out. Okay, now that's going to modify what we see in our numbers real quick. So obviously the negatives are now on the outside. When I took a half out of that 1, so kind of think for a second, if I take 1 divided by a half, because that's what factoring means, is we're dividing, that means there's a 2 left behind. I took the x to the negative 2 out, so that's on the outside. Ooh, I just caught that it should have been x to the negative 5/2, not 3/2. Hopefully you at home are correcting me. Which means it's x plus 2 to the negative 3/2 minus a negative 5/2. Then I got a plus. Let's see, so we took out a half, so that leaves we got a 3 behind. Then we have x to the negative 1, subtract a negative 2. And that x plus 2 to the negative 5/2, that's what we actually took out. Okay, so let's go back here. So we get a negative 1/2, x to the negative 2, x plus 2 to the negative 5/2. We got a 2. Alright, what is negative 3/2 plus 5/2? So that's actually x plus 2 to the first. So I can distribute that in. Plus 3, and that's really x to the first, so that's just 3x. And so I've got some like terms that I can combine. Yay! All right, so negative a half, x to the negative 3, x plus 2 to the negative 5 halves. 2x plus 3x is 5x plus 4. Okay. And so there's the factored form for that. All right, number 5, we're going to rationalize the denominator. So we're going to multiply by a very clever form of 1, which involves the conjugate. All right, so up in the numerator, I get 3 square root 6 plus 3 square root 7, just distributing the 3 in. And the whole reason for picking the conjugate is that allows us to do the difference of two squares process. So we get square root of 6 squared minus square root of 7 squared. Okay, so then we get 3 squared, so the numerator is going to stay the same. Denominator, we just end up with 6 minus 7, which that's actually negative 1. So we get negative 3 square root 6 minus 3 square root 7. And that's a perfectly fine answer. Nothing wrong with that at all. All right, number 6, again, we're going to rationalize this denominator by multiplying by the conjugate. Okay, up top, numerator, I'm just going to distribute that in. So 6x squared plus 6 square root 7. In the denominator, I get the difference of two squares. So it's x squared squared and square root of 7 squared. Okay, so cleaning that up a little bit, we get 6x squared plus 6 square root 7 over x to the 4th minus 7, and that's pretty much it. Not much we can do to pretty that up at all. All right, normally we want to rationalize the denominator, but on occasion we'll be asked to do the opposite. So rationalize the numerator. This still involves multiplying by the conjugate. So in this case, that would be the square root of x plus h plus the square root of x. And we'll do that on both numerator and denominator. Let's multiply by 1. And so this time the difference of two squares process shows up in the numerator. And the denominator, we just have this very lovely looking thing. All right, so that would be square root of x plus h squared minus the square root of x squared. Okay, so up top, the square roots end up just going away, and we get x plus h minus x. And again, we have that lovely denominator. Okay, and then what do you notice happens to the numerator? Hopefully notice that the x's cancel out. Now we're left with h over h times that lovely denominator. But here, the h's divide out. And so it actually simplifies down to 1 over the square root of x plus h plus the square root of x. Okay, number 8, exact same trick as 7. We're going to multiply by the conjugate of the numerator. So x plus 2 plus h plus x plus 2. Okay, and so our difference of two squares pattern shows up in the numerator this time. And we just have this nice, lovely, drawn out denominator. All right, x plus 2 plus h quantity squared, all with the square roots there. Okay, so up top, we have x plus 2 plus h minus x plus 2. Remember, it's both of them, so I'm going to put the parentheses there. And then we still have this very lovely denominator. That's going to simplify here in a second. Now, what do you notice happens with that numerator? When I distribute it in, I end up getting a minus x minus 2, and that cancels out with the x and the 2, and I'm just left with our h friend again. And it feels like we just did this party. Alright, and our h's divide out. And so we have 1 over x plus 2 plus h plus the square root of x plus 2. Yay!